Hi, welcome to another Algebra 1 video. In this video we're looking at section 2.5, which is solving compound inequalities. In this video we will learn about writing and graphing compound inequalities, and we will also learn how to solve compound inequalities and graph solutions on number lines. So let's begin with learning how to write and graph compound inequalities. So let's look at this compound inequality, which is written in words. It says that the number y is more than 0 and is less than 10. So based on this word inequality, I have to find out what the constraints of the variable y are. Well, I know that y is some number which we don't know, and we know that the first keyword tells us that y is more than 0. And the term for more than in maths is the greater than sign. And since the variable is y, and the second part of this constraint is 0, we know that y has to be greater than 0. Now let's look at the second phrase. Well, the second phrase tells us that y is less than 10. And the less than phrase tells us that something is using this symbol, the less than. So y is less than 10. And in the middle we know that it's using the and keyword, meaning that it includes these two. So this compound inequality tells us that y has to be greater than 0 and it has to be less than 10. So it's a combination of these two inequalities. Let's graph these two inequalities on a number line to see what it means. So I know that the beginning value of y in this compound inequality is that y has to be greater than 0. So our critical number should be 0, and we can mark it on the number line. And since it says it's greater than 0, it has to be an open circle. Now it's in this direction, so we can make an arrowhead in this direction, as all the positive numbers, or the numbers that are greater than 0, head in the rightwards direction. But here we also have a second constraint, which tells us that y also has to be less than 10. So let's mark 10 on the number line, and since it's less than, it has to be an open circle, and all the numbers that are less than 10 are going to be pointed in this direction, so we can draw an arrow in this direction. Well, here we can see that there is a collision occurring between the arrows, and they're intersecting. Well, since it says and, we know that this arrow cannot exceed the 0 part, because y has to be greater than 0. And similarly, y has to be less than 10. So this arrow that's pointing in this direction cannot exceed 10, because y is less than 10 even though it's greater than 0. So this inequality would turn out to look something like this. And so the values that satisfy this word equation for the number y is such that the values of y are greater than 0, where 0 is not included in y, but it ends at 10, where 10 is not included in y. Now there's another notation of how you can write y is greater than 0 and y is less than 10. Well, you can flip this one to say 0 is less than y, and then we also know that y is less than 10, so we can simply turn the two y's into one y and bring this part back here. So this is our compound inequality, and this is the graph that we get for this compound inequality. So 0 can be greater than 0, but it also has to be less than 10. Let's look at number 2 now, which says that a number a, which we don't know, is fewer than -6 or no less than -3. So again, in this inequality, which is a compound inequality, we have two constraints that we have to find out from this word inequality. Well, I can see in this phrase that the number a is fewer than -6. So I can rewrite that in mathematical terms, and we know that fewer than is represented by the less than sign. And this is going to give a is less than -6. And we're also given, instead of and, or. I'll tell you what or means in this situation. And the second phrase, or the second constraint of this problem, is that a is no less than -3. So what this means is that a is greater than or equal to -3, because it can't be less than -3, so it should include -3 and the numbers that are greater than -3. So this would be a is greater than or equal to -3. Now let's graph those inequalities on a number line to see what it means. So I know that by looking at this inequality, we know that the first critical point is -6, and we can mark that on the number line. And we also know that a is less than -6, and so we can put an open circle because it's less than -6. And since all numbers that are less than -6 are in the negative side, we can extend the ray in the negative direction. Now let's look at the second constraint, which tells us that the critical point is -3, and -3 is part of the solution because it has an equal sign in that greater than or equal to sign. So we can place a closed circle. And since it's greater than -3, that includes numbers that are towards the positive side, so we can extend the ray in the rightwards direction. So from the graph I can see that when we graph these two inequalities, we get no intersection. In fact, we have two parts of the inequality that are pointing in the opposite directions. And we could say this is a union because this means that our answer can either be less than -6, or instead of and, it can be greater than or equal to -3. So as long as our x is less than -6, or it could be greater than or equal to -3, then our a is defined. Now let's solve for some variables in some examples of compound inequalities. So in this first compound inequality, we're given that 5 is less than or equal to m plus 4, and m plus 4 is less than or equal to 10. So in other words, this means that m plus 4 is less than or equal to 10, and the second constraint which is placed in this inequality is that m plus 4 is greater than or equal to 5 if you flip around the sides. So how do we solve this compound inequality? Because we have two inequality signs in one inequality. Well, whatever we do in the center when we try to isolate the variable, and what I mean here is the inverse operations, we have to do it on both sides of the inequality. So to isolate m in this compound inequality, I know that I can subtract 4 from each side of the inequality. So if I do it from here, then I have to do it from here and here. And now I can just simplify this. So 4 and the -4 cancel out, giving me 0, plus the m, and then we get 5 minus 4 equals to 1, which is less than or equal to m, is less than or equal to 10 minus 4, which is 6. And we just bring down the inequality signs as they were. So let's graph this inequality we just solved on a number line and see where our solution lies. So we know that the first constraint of this and inequality is that m is less than or equal to 6. So we can plot a point here, which is going to be our 6. And the second constraint is that 1 is less than or equal to m, or in other words, m is greater than or equal to 1. So I know that based off of m being greater than or equal to 1, we can place a critical point here, which would be 1. And we know that both 6 and 1 are part of the solution for m because we have an equal sign in their inequality symbols. So we can place an open circle at 1 and at 6. And then we know that m is less than 6, so we can take a arrow towards the negative side. And on the m here, we can see that it's also greater than 1, so we can take it towards the positive side. Well, here what I see is that there's an intersection that's occurring. There's an overlap that's happening. So instead of taking it all the way there or all the way here, we would just close it off in this segment of that number line. So our overlap in this situation would look something like this. So here I can see that m is part of solutions that are greater than or equal to -1, which is in this direction, and it has to be less than or equal to -6, making sure that the numbers that we take account for satisfy for both of these inequalities that we just solved. Here we have another compound inequality, except in this case we have a situation in which we have an or. So let's begin solving this part of the or inequality. Well, here I can use the property of subtraction to subtract 1 from each side of the inequality. And by doing this, I get 2p is less than -8. And then I can use the property of division and divide each side of the inequality by 2, giving us p is less than -4, as -8 over 2 is -4. So here I can see that I can subtract 3 from each side of the inequality. And doing so, we get this part cancelled, and we're left with -2p is less than or equal to -1 minus 3, and this equals to -4. And now I can divide each side of the inequality by -2. Keep in mind that we're dividing by a negative number, so we have to flip the inequality sign in the next step. And then we cancel this out, and we're left with p is greater than or equal to -4 over -2, which is simply +2. Now let's graph this compound inequality on a number line. So I know that one of the constraints of this compound inequality says that p is less than -4. So our critical point would be -4. And since it's less than without an equal sign, it's going to be an open circle. And we also know that p is less than -4. So we can extend this ray in the leftwards direction, as numbers that are less than -4 are in the negative direction. And then here we're also given that p can also equal greater than or equal to 2. So our critical point would be 2 this time. And since it has an equal sign underneath that greater than sign, we can place a closed circle. And since p is greater than 2, we can extend this ray in the positive direction. In this case, since this is an or, Values that are in this part of the solution or in this part of the solution will satisfy the compound inequality. And this is it for section 2.5. I hope you found the concepts of solving compound inequalities useful and how you can understand the difference between and or graphs. Leave a comment in the comment section and provide feedback so I can improve my videos in the future. And I'll see you in the next video. Thanks for watching.